Hi friends, what you are observing is related to the chapter nuclei and the topic name is radioactivity. Here in this topic radioactivity they are asking in the question as the radioactive material A has decay constant 8 lambda and material B has decay constant lambda. Initially, they have same number of nuclei. After what time the ratio of number of nuclei of material B to that of A will be 1 by E. So, what they are asking us is to find what will be the time taken. So, n what is our formula means n is equal to n naught into e power minus lambda t. This is from radioactivity. The n is nothing but here what we are observing capital N is nothing but number of nuclei present at that instant. N naught is initial number of nuclei and lambda is decay constant. T is instantaneous time. Our target is to find the time. Now if you observe what happened, the number of nuclei initially they have mentioned that n naught is constant. In the two cases the number of nuclei initially are same. Let us enter into the data. The given data is n1 by n2 is equal to 1 by E. The number of nuclei are present at that instant of time t. The ratio is n1 by n2 is equal to 1 by E. Here we can also observe that the other information is lambda 1 is equal to 8 lambda and lambda 2 is equal to simply lambda. So this is the given data for us. Let us proceed. As n1 is equal to we have n naught into e power minus lambda t. Now what we can write here is the ratio n1 by n2 is equal to e power minus lambda 1 into t by e power minus lambda 2 into t. Here the n naught is same in the two cases. That's the reason we have taken as a constant. Therefore, n1 by n2 is equal to e power minus lambda 1 into t by e power minus lambda 2 into t. As n1 by n2 value what we have is 1 by e and e power minus lambda 1 means what we noticed is 8 lambda into t by e power what we can write here minus lambda 2 is given as lambda. So what we can write? E power minus 1 by e can be written as e power minus 1 and e power minus 8 lambda plus lambda minus lambda t goes to the numerator. E power minus lambda t I am taking into this term I am taking into numerator. Then what will happen? E power minus 8 lambda t plus lambda t. So e power minus 8 lambda t plus lambda t means e power minus 1 is equal to, now I can write it as e power minus 7 lambda t. Therefore what we can observe is equal to t is equal to 1 by 7 lambda. That is our answer. So here the question in that what we observed is, here if you enter into the question, radioactive material has decay constant. First one 8 lambda and second one they have given as lambda. They have given that number of nuclei ratio at that instant is 1 by E. Find the time where the number of nuclei becoming ratio is 1 by E, and a more information what they have given is that initial number of nuclei are same. Now what we have got is answer, that is 1 by 7 lambda. This is our answer, 1 by 7 lambda for the given question. Thank you. The question what you are observing now is related to the chapter name atoms. The topic is de Broglie. What we know about de Broglie is lambda is equal to h by p. So now what is lambda? De Broglie wavelength. What is lambda means we told de Broglie wavelength. H is Planck's constant and P is called linear momentum. Now P kinetic energy and linear momentum relation what we have is kinetic energy is equal to P square by 2m. From this kinetic energy and P square by 2m relation what we can write P kinetic momentum can also be written as root over square root of 2m into kinetic energy. 2m into kinetic energy. Therefore, our formula for de Broglie wavelength we can write as lambda is equal to h by root over 2m into kinetic energy. Now, in our question, if you go back to the question and observe, the question is de Broglie wavelength of neutron in thermal equilibrium with heavy water at temperature T and mass m is. My dear students, here if you observe the kinetic energy formula what we had from earlier in the first year topic is kinetic energy can be written as 3 by 2 kT. This is the formula from where we got, that is kinetic theory of gases, that kinetic energy of that neutron we can take now it as 3 by 2 kT, where K is called Boltzmann constant, T is absolute temperature and K is kinetic energy. So now if you substitute this formula in our de Broglie, then what we can write, lambda is equal to h by root over 2m into 3 by 2, what we can write, kt. Here 2 and 2 will be cancelled and what we can notice finally is lambda is equal to h by root over 3m kT. Here this is the final formula we can observe. Please my dear friends note that this lambda is de Broglie wavelength, h is Planck's constant, m is mass of the particle, k is the Boltzmann constant, capital T is absolute temperature. This is our answer for the given question. So our option what we can find is the first option, that is lambda is equal to h by root over 3m kT. Thank you.